So chapter 2, kinematics. First of all, we will go through a few terms here. The first point, distance. Total length move irrespective of directions. Okay, so we just look at the magnitude only. No need to care about the direction. This is a scalar quantity. Displacement, distance in a certain direction. So we look at the magnitude as well as the direction. For example, 3 meters to the left, the displacement is negative 3 meters. So next one, speed, distance traveled per unit time, no direction. So from here, we can see that speed is a scalar quantity because they are using distance divided by time. Velocity, the rates of change of displacement. So in other words, displacement over time. Okay, displacement over time. So one of the example that I can give here is something like this. So let's say if you have an object, move in a circle, and come back to the starting point. Okay, now let's say the radius is 1 meter. 1 meter, and it takes, let's say, 5 seconds to move one round. So in this case, the distance is equal to 2 pi r. So 2 pi r, 2 pi 1. Okay, so end up with 2 pi. So 2 pi is in decimal. 2 pi is 6.283. 6.283. 331. 31 and so on. Okay, so if I round off to 3 significant, 6.28. Okay, displacement we use S. Displacement is where you look at the starting point and the end point. Okay, so if they are staying together, so displacement is 0. Okay, so if they are not the same point, then you just join up with a straight line. The straight lines represent the displacement. Okay, so we look at the starting point and the end point. And now speed. Speed. We take 6.2831 divided by 5. And then we get the speed. So the speed is 1.26 meter. This is meter per second. Okay, velocity. Velocity is displacement over time. So displacement 0 times 5. So the velocity is 0. So you will see something like this. Okay, so for 4 of these. Now we look at acceleration. The rate of change of velocity. So we have a formula. A equal to V minus U. V minus U is the change of velocity over time. So when you over time, it becomes rate. Change of velocity over time. Okay, so this is the acceleration formula. We'll see more example later. We move on to the graph, displacement time graph. So that means the y-axis, the vertical axis is displacement, S is displacement. The horizontal axis is time, displacement versus time. So the concept of this displacement time graph is the gradient of the graph is the velocity. So if you see this straight line, it has the same gradient all the way. Same gradient, same velocity. So we call it constant velocity or constant speed. Okay, so constant speed, but this is forward, move forward, because it's positive velocity. So move forward. Okay, so if you have a straight line going down, so if you go and count the gradient, you will get a negative value. Negative velocity means it is going backward, but constant speed, going backward with constant speed, okay? Because the gradient is the same gradient all the way. Okay, so going backward with constant speed. The next one, the third graph, is a curve like this. So if you look at the gradient over here is not so steep, then the gradient here is steeper. So showing that the gradient increase means increase in velocity. So increase in velocity is acceleration. So acceleration. Whereas the fourth graph, if you see a horizontal line, that means it has no change in displacement. So this is where the object is stationary. So we have four types of graph. Okay. Now, sometimes we put the graph together in situation like this. So for example, curve followed by straight line, followed by horizontal line, followed by going down. Okay, so for this curve, you have to know acceleration. For this part, straight line, constant velocity. So that means it moves faster and faster until a particular speed, it remains at the same speed. And then after that, stop and then go back with constant velocity. So they may put together a few types of these put together, and they ask you to count something or they ask you to find something. Okay, now the next type of graph is velocity time graph. So velocity is the vertical axis, the horizontal axis is time, the gradient is the acceleration. You see just now gradient is velocity, now gradient is acceleration. So to easily remember what gradient represents, right, that is actually a way. You just take the y-axis divided by the x-axis. You know, displacement over time, velocity. Now, velocity over time, acceleration. So by using this idea, it helps you to remember the gradient represent what. Okay, so if you want to find out the area under the graph, so the area under the graph represents something, represent change in velocity, change in displacement. Okay, change in displacement. So to remember the area represent change in displacement, you just take velocity, multiply with time, then you should think of displacement. As we know from here, right? Velocity is displacement over time. So displacement is velocity multiplied with time. The basic concept is like that. So this multiply with this, velocity multiply with time. So what you get is displacement. Okay, so they call it change in displacement. And you have to be careful with something like this. I give you a special example. Let's say sometimes your graph is just like this, where the area is always the positive area. Okay, positive area. So let's say I just take a quick revision here. So this is velocity, this is time, and let's say this is 0, this is 3, and let's say this is 5, and let's say the time here is 2. Okay, so if I want to find out the area, so I just use trapezium, and the trapezium's formula is 1/2, add up the parallel sides, 3 plus 5, and then you multiply with 2. So 8/2 is 4, 4 times 2, 8. So the area is 8. If the area is just positive only, okay, so if the area is just positive area, and then displacement equal to distance. Displacement equal to distance. Okay, so that means this 8 meter, you can call it displacement. You can also call it distance. So you can call it displacement, or you can call it distance is equal to 8 meter. But sometimes your area, right, have positive area as well as negative area. For example, something like this. Okay, so we have positive area here. We have negative area over here. Okay, let's say I put value 0, and then this is 2, and then let's say this is 4, and then let's say this is 5, and down here, let's say this is negative 3. So velocity time. So if you have positive area and negative area, below of the axis is negative area, then you must be careful. You must be careful. So for example, right, let's say I just count the area separately first. Area 1, area 2, area 2. Okay, so we need to know that if they are going below of the horizontal axis, that means they are having negative velocity. Negative velocity means return or move backwards. So this is moving backwards. Okay, so let's see how to find the area 1 and the area 2. So area 1, I can use trapezium. So let's say this point is 2 also. Okay, so I take 2, 1 over 2, then add up the parallel sides, 2 plus 4, multiply with the height, which is 2 also. And then I get 6. 6 over 2 is 3. 3 times 2 is 6. 6 meter for area 1. But for area 2, 1 over 2, triangle, 1, 3. So the area is 1.5. But remember, this is negative area. But of course, when I count, I don't include the negative. So area is normally taking positive value. Okay, but we need to know if you have negative, if you have area below of the t-axis. So distance, we just add the two values, 6 plus 1.5, 7.5 meter. But displacement, right, we have to take 6 minus 1.5 to get 4.5. So this is the small difference between the distance and the displacement. So of course, for displacement, why we need to minus? I draw a motion diagram to let you see. So from
would they ask you to use a velocity time graph to calculate the total distance moved instead of displacement?
Yes, it's possible for them to ask. Yeah. So count the total distance instead of displacement. So it's a famous question after all. Okay, famous question. Yeah. Okay. So let's come back to our discussion here.
Yeah.
So you want to see why the displacement is 4.5. So basically, it's because A1 is 6 meter, right? That is where it moved forward by 6 meter forward. Then 1.5 is where it moved backward by 1.5. So move backwards 1.5. So 6 meter, and then move backward 1.5 meter. So displacement is where we look at the starting point and the end point. So from here to here, that is the displacement. So you see, this is 6 minus 1.5 to get the 4.5. So I just draw out how it moved and why the displacement is 4.5. So basically, because the idea of displacement is starting point to end point. Okay, so now let's see the first graph. Straight line from origin. You know, gradient is the acceleration. So if you look at the graph, it has the same gradient all the time. So this is called constant acceleration. Constant acceleration. That means the acceleration is the same value. Okay? It's the same value. So for example, let's say if your acceleration is 3 meter per second per second. So constant acceleration. And actually what is meant by constant acceleration? So I give you one example. Constant acceleration means in every 1 second, the particle increase its speed by 3 meter per second. So let's say, for example, initially the speed is, let's say, 4 meter per second. So after 1 second, you should expect it to increase by 3 meter per second. So should be 7 meter per second. It increases by 3. Increases by 3. So after 1 more second, you should expect it to increase by another 3. So that is 10 meter per second, and so on. So every 1 second, the speed increased by 3 meter per second. So that is the idea of the constant acceleration here. Deceleration, slowing down. If you see the gradient is negative. Negative gradient, deceleration. So slowing down. So horizontal, constant speed, same value. This V is the same all the time, constant speed. Compared to just now, stationary. Now, constant speed. Stationary, 0 velocity. So the graph is here. Okay, so we move on. Uniform acceleration and straight line motion equations. So we have, we call this SUVAT. So there are 5 quantities here. S stands for displacement, U is initial velocity, V is final velocity, A must be the uniform acceleration, that means constant acceleration, T is the time. Okay, 5 quantities. Okay, and we have 5 formula. So 5 formula. So each of these formula, we use it when one of the quantities is missing. For example, V equal to U plus AT. We use this when you don't know. When the question is not asking displacement and the question never give you anything on displacement, then you use V equal to U plus AT. The second formula, S equal to UT plus half AT squared. We use this formula when you are not given with velocity, the V, the final velocity is not given. They never ask and they don't give you final velocity, and then you use this. S equal to half U plus V times T. This formula is used when you are not given with acceleration and the question never asks for acceleration. S equal to Vt minus half At squared. We use this formula when the question never asks for initial velocity and they never give you any information on initial velocity. And finally, when you don't know T and the question never asks for T, then you use this formula. Okay, so of course we need to practice. Okay, we need to practice these 5 formula. And for the case where the object is experiencing free fall, then you have to use 9.81 as your acceleration. Okay, acceleration 9.81. So maybe you're wondering, should I use 9.81 or negative 9.81? So we will discuss this afterwards. Huh? Okay, so there is a way to get, yes.
These formulas don't need to memorize one, right?
Yeah. It's given. It's given, but let me. It's given. This formula is.
You're lagging a bit.
So, lagging. Yeah. Okay, let me see. 9702 physics past paper. If it lags badly, you just let me know. Then I try to use maybe mobile data. Okay, let me see for the latest exam questions whether there's still giving us. They give us data formulae. Okay, you see they give only two. S equal to ut plus half at square, v square equal to u square plus 2as. So need to memorize or not? Somehow need also lah.
Yeah.
Okay. Now we practice first. Okay, let me see which question is suitable here. Okay, so these questions, let us discuss together. Question 6. A hot air balloon is moving vertically upwards with a constant speed of 3 meters per second. A sandbag is dropped from the balloon. It takes 5 seconds for the sandbag to fall to the ground. What was the height of the balloon when the sandbag was released? Okay, so that means they want us to find the height, the S. The S, they ask for the S. Okay, so a sandbag is dropped from the balloon. So that means this is free fall. Free fall. Okay, free fall. So if it's free fall, then of course we use A equal to 9.81. So the question is, do we need negative or no need? Okay, so we need to make ourselves very clear on this. Okay, so negative or no need negative. So it depends on your assumption. Okay, need negative or not. Okay. If you assume upwards to be positive, then A equal to negative 9.81, because this is acceleration due to gravity, which act downwards. So if you assume upwards to be positive, then A is negative 9.81. But if you assume downward to be positive, then A equal to 9.81. No need negative. So this is how we determine. whether we need negative or no need negative. It depends on your setting. If you set upwards to be positive, then A equal to negative 9.81. If you set downward to be positive, then no need negative for the 9.81. Normally, in practical, we will use this case if the object move up and down. If the object move up and down, we will assume upwards to be positive, downwards to be negative. We will use the second scenario, assume downward is positive if the object move down only. Normally, we will put it in that way. If the object move down only, we assume down to be positive. If the object move up and down, and then we assume up to be positive, down is negative. Okay, so let's see this. The hot air balloon is moving vertically upwards. So we have up. A sandbag is drop, we have down. So if you have up and down, up positive, down negative. And how we use this, constant speeds of 3 meters per second. So this is the initial, this is the speed of the hot air balloon. Hot air balloon. So you have to know the hot air balloon carries the sandbag. So if the hot air balloon move at 3 meters per second, so the sandbag will move at 3 meters per second also. This is the initial speed of the sandbag. Initial speed of the sandbag, because the hot air balloon and the sandbag have the same speed. Until the moment when you release the sandbag, it starts to experiencing free fall. It takes 5 seconds to reach the ground. Okay, so now we have U, A. Okay, need negative or not? We need because we assume up to be positive, down to be negative. So need negative. So are you trying to ask something or say something?
I said don't. I said need negative.
Need negative, yes, yeah. We need negative because we have up and down. Okay, so we have U, we have A. Okay, let's circle now. We have U, we have A, we have T, we have V. Sorry, we have S. We don't have V. So the formula that we need to choose is S equal to UT plus half AT square. So this is the formula which does not involve the V. Okay, so now we substitute value. We substitute value into the formula. Okay, 3, 5, half, negative 9.81, 5 square. Okay, then we just count. We will get negative 108. Negative 108. Of course, this is reasonable because we set upwards to be positive. So the sandbag is going down by 108 meters. So, but they ask for the height. They are not asking for displacement. Displacement is negative 108, but the height is 108. Okay, so B. Okay, now let's see another one. Okay, so let's look at question 7. Question 7. The velocity time graph for a train starting at one station and stopping at the next is shown. Okay. Another train has double the acceleration, but the same maximum speed and the same deceleration. Okay. So they give 3 information. double the acceleration. Okay, that means the gradient is double compared to this. The gradient is double. So if the gradient is double, right? So we should expect it to be like, the gradient is going to be like double. Something like this. Okay, this is double, the gradient of this one. Then same maximum speed. This is the maximum speed, same. So how long should we go? We don't know yet. And the same deceleration. Same deceleration means same gradient when it goes down. When it goes down, same deceleration. So we don't know how long should we extend the maximum speed after that same deceleration. Okay. So what we know is here, starting at one station, stopping at the next station. So which velocity time graph on the same scale show the motion of this train between the two stations? Okay, so between the same station, that means it has the same distance or same displacement. We should expect area under graph to be the same. Area under graph to be the same. Okay. So let's see our choice here. Okay. So this one, double the acceleration. This part seems to be accepted. This one, double the acceleration, accepted. Double the acceleration, double the acceleration. So it seems like 4 of these are correct for double of the acceleration. Maximum speed is this. Correct, 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 and correct. Same deceleration. If you see the deceleration, it's like this. 1, 2, 3, 4, 5, 6, 7, 8. A rectangle of 16 boxes cut diagonally. 2, 3. This one seems to be correct. Seems to be correct also. Seems to be correct. And seems to be correct. Okay. So then how to determine which one is wrong? So we have to count the area under the graph. They must have the same area under the graph. Okay, so let's count this. For this case, I separate it into a triangle. A1, A2, and another triangle, A3. So A1, 1 over 2, the base, 1, 2, 3, 4, the height, 1, 2, 3, 4, 5, 6, 7, 8. 4 by 8, 16. Area 2, 1, 2, 3, 4, 5, 5 times 8, 40. Area 3, 1 over 2, the base is 2 units, the height is 8 units. 8. So total up 56, 60, 64. 64 units. So in order to choose the same answer, you have to choose the one with 64 units. Okay, so this one, let's check first. Area 1, 1 over 2, 2 by 8. 2 by 8. So this is 8 units. Area 2, area 2, 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 8. 40. Then area 3. Okay, area 3, 1 over 2, 2 times 8, which is 8. So the total distance is 56. So this is wrong. Okay, so area 1, same with the A, 40. Area 2, 1, 2, 3, 4, 5, 6. 6 times 8. Area 3, same also. It's area 3, same with the part A. So 1 over 2, 2 times 8. 8. So this is 64. Okay, so this is the answer. So you have to choose the answer with same distance, same area under the graph. As the question said, it is between two same stations. So we have to choose the one which is in that way. Okay. Now let's move on. Let's see. Okay, so let us look at these questions. The variation with time t of the velocity v of the two cars P and Q is shown in figure 2.1. So you see this figure 2.1. So we have car Q. As you see, the graph has a greater gradient, so you should expect this to accelerate faster. And then car P is kind of flat. This has a small acceleration. Okay, the cars travel in the same direction along a straight road. Car P passes car Q at time t equal to 0. So that means here. Okay, so it passes through car P, passes through car Q. As you see, car Q is not moving at the beginning, and car P is moving at 20 meters per second. So it passes through. It passes through car Q. Okay, so in other words, that means they both start from the same point. Okay, at t equal to 0. So the speed limits for cars on the road is 100 km per hour. 100 km per hour. State and explain whether car Q exceed the speed limit. Okay, so in order to determine that car Q exceed the speed limit, what we need to do is we look at the graph again. So car Q reach a maximum of 30 meter per second. You want to see whether this 30 meter per second exceed the speed limit of 100 km per hour or not. So we have to do conversion. Okay, so 30 meter per second equal to 30 meter over 1 second. So we convert the numerator to km. 30 over 1000 to km. 1 second divide by 60 to minute, divide by 60 again to hour. Okay, then we can find out the number in km per hour. So we get 108 km per hour. Okay, so in that case, km per hour. So I follow their way, km h -1. So car Q exceeds the speed limit. as this is more than 100. Okay. Part B, calculate the acceleration of car P. So acceleration of car P, you look at the graph again. So to find the acceleration, we find the gradient of the graph. Gradient represents acceleration. So we look at this point, 0, 20. Then we look at this point, 12. Bring this to the side. 24. 4 boxes. Okay, 24. 12, 24. So we find the gradients by using the gradients formula. 24 minus 20 over 12 minus 0. There's the gradients formula. So we count it here. 24 minus 20, 12 minus 0. So we count this, we get 0.333 ms negative 2. Okay, so we get this. Part C, determine the distance between the two cars at time t equal to 12. T equal to 12, distance. So as we discussed before, if they have positive area, you see this one, the area is positive area for car Q, let's say. Car Q, positive area. So the displacement is equal to the distance. Of course, the displacement is area under the graph. Area under the graph is the distance straight away. For car P, you have to use this. This is area under the graph also. It's a trapezium shape for car P. Okay, so let's count the area under the graph for car P first. So car P, here to here. Okay, I do the calculation here. By right, we have supposed to do down there. So to make ourselves more convenient in referring to the graph. So we do it here. So car P, distance is area under the graph, which is 1 over 2. I'm going to add out the parallel side, 20 plus 24. Multiply with the height, here to here, 12. Then I count this, 264. Now we're going to count car Q. The distance is area under the graph. The area under the graph is a triangle. So we do 1 over 2 base times height. Okay. So as we discussed before, they both start together. So car P move 264, car Q move 180 meter after 12 seconds. So what they ask in the question is they want us to determine the distance between the two cars. Distance between the two cars. So imagine they both start at origin O. Car P move 264. Car Q move 180. And what they ask is distance between the two cars. So they're asking this. So we minus 264 minus 180. So 264 minus 180, and then you get 84. So that's the answer for part C, 84 meter. Okay. Paper 2, we need to think more. Okay, 84 meter. Then part D. From time t equal to 12 seconds, the velocity of each car remain constant at its value at t equal to 12 seconds. Determine the time t at which car Q passes car P. So if you look at the graph again, according to what they said, right, they remain their velocity at this time. So that means it become horizontal. This one also become horizontal. Okay, so car Q is faster now. So at the end of a particular moment, car Q should passes through car P again. Okay, so and we want to find out the time when this happens. So we should expect both to have the same area under the graph. The same area under the graph. Okay, so imagine the car Q passes through car P at time t. So in order to find that time t, right? Okay, so basically it should have the same area. Okay, so we do it like this. Distance of car Q equal to distance of car P. So this is the working for part D. I do it here so that I can look at the graph at the same time. So I already count from for the first 12 seconds, car Q move 180 meter per second. Move 180 meter. Then after that, you should expect car Q to move with area under the graph as a rectangle shape. So I can count the area of rectangle easily for this part. The height 30, the base is t minus 12. 30 t minus 12. So this is the area under this column, this particular area. Now for car P has moved 264 from the first 12 seconds, 264. Now car P have to move by another column of rectangle like this. Okay, so the area is 24 multiplied with t minus 12. 24 t minus 12. And we solve the equation. I bring the 180 over. So I get 84. 24t. 24 minus 12. Okay, we get 12. 30t. 30 times 12. 360. Just now this one, mistake. 24 times 12. 288. 60. 84 minus 288 plus 360. 156. T equal to 26 seconds. So we get the time. At the time 26 seconds, then meet up again.